Right. So welcome to the next edition of Mitten Times. Can you hear me all right? Nice. Okay. Thank you. Thank you all for coming. Let me please help me welcome Vladimír Kadlec from STRV, who is a machine learning engineer. He's going to be talking about how to not, or how to run correctly or with some mistakes A/B tests. I'm hoping that we're gonna learn quite a bit, because every time I hear Vladia speaking, it's very informative. So the floor is yours. Thank you.
Thank you. Thank you. I hope that I will. I hope that I will fulfill your expectations, Tonda. I didn't expect that. So first of all, I would like to tell you more about myself. I will just wait for guys, because you probably don't see it in a Zoom, but there are some technical issues, but it seems that everything is okay. So my name is Vladimír Kadlec. I'm from STRV, and I spent 10 years and something at Seznam. And then I was 1 year at Auka, and now I am in STRV as a machine learning engineer. Most of the presentation, most of my experience with A/B testing is from Seznam. It's mainly about A/B testing web applications or web services. Okay. So this is my favorite quote from Lord Kelvin: "If you cannot measure it, you cannot improve it." I think this is very, very important thing to measure things. I've met several projects, and several times that you have an idea. The idea is great, so you program it, deploy it, and then you are happy because you deployed your idea. But if you don't measure the impact of the idea, you don't know anything about the success. So measuring, I think, is the key for improvement. So A/B testing. A/B testing is actually a very old thing. I found some experiment from 18th century. By James Lind, who did experiments on STRV. In Česky, it's kurdě. It's a disease, and vitamin C helps a lot by this disease. And he actually did some very cruel experiments, and someone eventually have to pass away. But some it was basically from sailors were affected by this disease. So this is really old. The statistics for A/B testing is mainly from 19th century, but all I wanted to say that it's basically in clinical trials has a very long history. So this is not something new or new for online world. So there is a huge foundation behind A/B testing. But A/B testing in the online world is very different thing from clinical trials. So keep that in mind. Yeah, sometimes it's called split testing, and sometimes in bucket testing. I think at Microsoft they call it flies or something like that. So it has some funny names. I will stick to A/B testing, A/B testing words. Okay, so in internet world, what could you test actually? Basically anything you can imagine of. Email marketing, digital advertising. At Seznam, I spent my 10 years at search department, and I think Tonda was at advertisement department. So maybe Tonda knows about more than me about A/B testing for digital advertising. in a typical website has a front-end part and back-end part. In front-end part, you can test position of the elements, colors, font, whatever, and also a content of the website. For example, in web search, it's for example, order of the search result. For example, speed. If you speed up your website, you get higher revenue. But it's not always the case. But it's good. It's definitely good to test it. So you can test design and content as well. I think this is good. And I have also by here for machine learning models performance because I'm glad that Mathieu is here, because we had a lot of experiments at CESNAM where our machine learning models perform really well on testing data. I mean, standard machine learning loop. But when it comes to A/B testing, it was really difficult to apply this to winning A/B tests. Well, we had a lot of successful models on testing data, but not so many successes on human with real users. And unfortunately, this is typical for A/B testing world, that most of the experiments are just fail. But yeah, that's it. So test set versus real users for machine learning. I think this is really sometimes it's overlooked because when I'm a machine learning engineer, and when something works really well on my test set, I say, okay, super. I have a training set, I have validation set, on test set, it's performing super well, so it has to be good in production. But it's not it's not always the case, and it could be caused by many reasons. For example, the distribution of the data in test set is different from the distribution of users, or the implementation is wrong, or well, there could be many different aspects. So unless you deploy the model to the production and actually measure it on real users by, for example, A/B testing, until then you don't know the real impact of the thing. So what do I mean by A/B testing? You split your users into two groups: version A, variation A, or variation B. In some sometimes it's called original or new. Some authors call it champion and challenger. Champion is the current version, or in medicine world is usually called control group and treatment group. So we have two groups of users. We show them in our internet world two variations of our website or our application, and we measure some metrics by observing the behavior of the users, and then we eventually decide whether one version is better than the other. So here we have an example with conversions, but I will get into the metrics. There are much more metrics than just conversions. This was the classical example. I have here example of not so common thing. There is a technique called team draft interleaving. You may never hear about it, but it's pretty useful for applications where you have more elements. For example, in web search, you have more search result. If you have image search, you have more images. And this is an example from Netflix. They have this is, I think, from the recommender. This is they have two recommenders ranked the movies are rank A, rank B, and basically they mixed these two rankers into one ranker, and this combination of these two rankers is shown to one user. So there is no need to split users into two groups. This is advantage of this method, I think. There are some disadvantages as well, but I just want to point out that the splitting users into two groups in A/B testing, this is not the only option. You can use this technique as well if you have if you want to test that data like this, if you have some items, sorted items by some criterion, and for example you would like to test which sort is better, there are problems with that. It's not that simple, just that you just simply do A, B, A, B, and A, B. It's much more difficult than that. I'm pretty sure that Netflix is aware as well. But if you have such a data or such a, let's say, application, look at this method. I think it's really useful because you don't have, as I said, you don't have to split users, and you have just one user, and the user choose which pill. I have here the matrix example. Usually the user choose the version she likes more. So that's I think that's pretty good. The method has some problems, but has some advantages as well. And we use this method in SNAM as well. Not for image search, though I think only for web search. By the way, there are links in the presentation, so I'm not sure if Tonda will share it, but so there are links to the these are not just links to the domains, but there are actual links in this presentation, so you will have it there and you can look into them. Okay, last thing about Interleaving. It was not invited by Netflix, of course, because this is, I think this tech blog is from 2017, but we use it at SNAM, well, 10 years ago. So it is much older technique. Okay, so how to measure the user behavior? It's measured by something that's called metrics, usually. So this is called for Ronnie Kohavi. I met this guy twice, and he used to be a lead of experimentation platform at Microsoft. And this is from his presentation, and where he said that a typical Bing scorecard has more than 2,000 metrics. And I asked him how it's possible to evaluate such an experiment with 2,000 metrics, and he told me that they have a kind of dashboard where he just looked at green metrics that were statistically significant, and so they had some kind of visualization of these 2,000 metrics. So you can really highlight what's changed by the test, what's different between these two groups. I think this is really cool. The thing is that it costs you something to build such a platform. But I can really recommend it because then you know how to how to build better products, and you don't do just estimates. So this is example from Bing, and I will give you some more example about metrics later. First of all, you can measure data quality. I think this is sometimes it's overlooked as well. The data quality in A/B testing is absolutely crucial. If you don't, for example, log your users' behavior correctly, then you just measure noise. So I really, from my experience, really recommend double check, triple check your data pipeline, your logging facilities. For example, I have here some examples. For example, if a user clicks and you measure it by JavaScript, you get different data from your backend access log on your web server. This is because it's JavaScript interpretation in browser is problematic. Sometimes some packets are lost. Users are on slow internet connection. So well, I can recommend the backend data, which in my perspective are more reliable. On the other hand, sometimes it's more problematic to get them because, for example, you're a small company and your web server is managed in some cloud. You don't have access to that. So I understand there are technical issues, but data loss is something that you simply don't want in A/B testing. A recent thing, Google Analytics, I found this recently, last month or something. In Google Analytics 4, user counts are estimated. Even if you have 100, if you don't sample, if your website is small enough, and there is a 100% sample rate, or whatever they call to, all these user counts are estimated. It's used a method called hyperlog plus, and it's described in this article. And I'm sorry, I forgot the name of the person who wrote the article, but he is a really influencer in A/B testing world, and there is a comparison how this estimate affects A/B testing. So I asked my network at LinkedIn, they are professionals on analytics, how to cope with this. And the person who wrote the article, they say use influencer in A/B testing world, and there is a comparison how this estimate affects A/B testing. Okay, thank you. So yeah, I can recommend read that. They recommend, in Google Analytics, they recommend pull all your data to BigQuery and do your own analysis. So if you use Google Analytics for A/B testing, I know that Google Optimize will end this year, but there are techniques how to cope with that. And and if your A/B testing results are based on a user count given by Google Analytics 4, I really recommend read this article and just use BigQuery or something like that to compute your own values. Then we have something called sample ratio mismatch, which is basically simple thing. If your number of users in version A and version B is different, for some techniques it's not that important. For some techniques it's very important. So yeah, triple check that you have the same number of users in both groups. And of course, cookies are not users. If you do some web experiments, you know this. Well, I can recommend do experiments on logged in users. That's most simple one. I know sometimes it's not possible. Yeah, and eventually cookies will end, so so that's problematic as well. Okay, so metrics for online evaluation. Basically, you want some criterion that will decide whether the version B is better than version A. So this is sometimes called overall evaluation criterion or overall acceptance criterion. Usually this matrix has something which is called sensitivity and directionality. The sensitivity is how small changes is you can measure by these metrics. Some metrics are not so sensitive. For example, something like a long-term loyalty. If your users are leaving your service, or if you have more users, these metrics these metrics are really delayed. If you run a 14 days test, you probably it's hard to measure something like user loyalty. Depends how do you measure it. It depends how many users you have, of course. But so that's one thing. The sensitivity, directionality. It means that usually the metrics should be monotonous. I mean, if the metrics go high, it's better, or it's worse. But it should be just one way not that the metric has some kind of peak in the middle, and and some metrics are, of course, some metrics are good and bad. So you have to know the direction. So here are some, for examples, typical metrics like click-through rate and clicks per users. Time to first click, we used that, but there are a lot of. I didn't want to give you thousands of examples, but because there are a lot of useful metrics. There is a tutorial from people from Yandex, Russian search engine, and this was a one-day tutorial just for creating good metrics for online evaluation. So what I can recommend, use more than one metric. One metric is usually not enough because it's very easy to, for example, boost click-through rate. You just make some element on the website bigger. You make some button bigger and you boost your click-through rate, or you put some image of Kitty there, and then, of course. But usually, if some metric goes high, then other metrics go low. So I really recommend to use more than one and to know what actually happened. Okay, so how to compute the results? So for each metric, unfortunately, for each metric, you have to run statistical tests to confirm that difference are not just due to chance. Well, I saw it many times as well, that people tend to just compare. For example, if we have click-through rate, people just compare, hey, version B has better or higher click-through rate. Let's use version B because it's better. But it's not the case. It could be just a chance, just by chance, because I don't know. It's the users in version B was randomized in that way that it was just it was just purely random. So one way from this is that you would have to repeat the experiment, for example, million times, and then do some kind of average. But usually you cannot repeat. Imagine that you would repeat 2 weeks experiment million times. You know, it's not doable, and that's why we have statistical tests to give you some information about whether these results are statistically I'm missing the word now. Significant. Thank you. It will be on the next slide, probably. Thank you. So there are basically two approaches. Frequentist approach. There is a test setup with so-called null hypothesis. I won't you worry about if it's any formulas. Don't worry. So the null hypothesis test just say, okay, version A is the same as a version B, and all this approach tries to reject this null hypothesis. The typical setup is that you have so-called significance level to 5%. It's called p-value after the test if you actually compute this, or type 1 error. But okay, I don't want to go into many details there. Don't forget statistical power as well. Sometimes some tools, even some A/B testing tools, just provides you significance level, but not the power. And the power basically says if there is, in fact, if in reality, if the version B is actually better than version A, what is the probability then you will that you will see it in your by this data? So and it's usually it's set by 80%. These numbers are purely from some kind of experience or history. There is no math behind these numbers. Okay, so the thing is, if you would like to much small numbers, or if you would like to have a statistical power, let's say 90%, you will need much more data. So these numbers are, well, with a very long history, prove that these are reasonable numbers for significant level and statistical power. Then you need something which is called baseline. This is usually you have some kind of version of the system, and you are able from the history compute the metrics from historical data. For example, click-through rate, we know that on this element is usually 5%. So this baseline is used then with something called minimum detectable effect, and with all these numbers, it's all these numbers are used to compute required sample size. So don't miss any of these numbers. Sometimes, as I said, sometimes people tend to look just on a significance level or overlook the minimum detectable effect. I will give you some examples on the next slide. So this was a so-called frequentist approach. The problem is that the math, the statistics behind this is rather not intuitive at all. These p-values are, well, there are a lot of non-intuitivity behind this. But fortunately, there is a Bayesian approach as well. And by this, again, I won't give you any formulas there. You can easily find them. The Bayesian approach gives you direct probability that by this matrix, version B beats A. It's I think this is one advantage, that you have direct probability of this. Of course, 50-50 is the baseline. It's like tossing the coin, and then it depends on your data. Then also the Bayesian approach can give you an answer: how much would I lose how much would I lose if I'm wrong? That means, okay, the fact is that version B is actually worse than version A, but in my test setup, I measured that version B is better than version A. So I was wrong, but by this method you can calculate the risk. So it's very business. I think this is very practical thing, and of course expected uplift. If you are right and your version B is actually in reality better, then how much you gain. Because I saw some setups where the expected loss was very tiny, so the risk was small, and the probable uplift was not so high. But because, for example, new design and your manager likes it more or whatever, so you can safely say, okay, the uplift is not so big, but the risk of losing something is very small, so you can deploy it and in a very safe way. So these are two approaches how to compute the frequentist and Bayesian approach. You can of course compute both from your numbers. So usually the A/B testing tools have one or the other. VWO have a Bayesian approach, and I can recommend it. Because it's much more clear, I think. All right, this is a joke about the Bayesian versus frequentist. I think I will skip this. You can look at XKCD. Basically, it says that the Bayesian approach is something based on a history. There is So this is a joke about this. There is some controversy behind this cartoon. Probably the most important thing in A/B testing, a sample size or number of users or number of visitors of your application or web page. So if we have set up like the baseline conversion rate is 5%, and we would like to detect 5% 5% effect, meaning that this baseline will go from 4.75 to 5.25. So these are kind of limits you could detect this, and you set the p-value and statistical power to recommended numbers. Then you need 120,000 users per variant. So that's I think this is the biggest issue with A/B testing, that you need a lot of users or a lot of data. I really recommend use just one user for one variant. Sometimes this websites cope with this, that they will just for example, next day they will serve the same user a different variant, but I cannot really recommend this. So to detect from the baseline of 5% is kind of typical in online work, I think. Well, it depends, of course, depends on your business, depends on your metric, but this is kind of typical example, and you need really a lot of users. So keep that in mind. There is a link to the calculator where you can actually.
We have a question. Is it okay to ask it now?
Yeah, sure.
Thank you. I just wanted to ask you where the number comes from.
Yeah, from this calculator. There is a link.
Yeah, but I mean, what's the principle? Is like from normal distribution, or where does it come from?
Yeah, exactly. This is well, I don't remember the formula. Okay, but basically, what it computes is that if you would like to have a statistically significant to detect statistically significant differences by this, let's say, limits, and by this two parameters, then you need to use these numbers of users.
Distribution to
Yeah. Well, all of this, I think it's based on t-test. I'm not sure about this, to be honest. So it assumes normal distribution. Sure.
Thank you.
And this works only for binary. Okay, so true, not true, or click, not click. Yeah, for yeah. Then I really recommend this Evan Miller's calculators. There are many some more. So well, this is for frequentist approach, but this guy is real. He has a lot of articles about Bayesian A/B testing on his website, and there are the formulas as well with proofs that that is correct. And okay, so this was for 5% minimal detectable effect. But if you would like to detect just 1% effect, for example, if your business is large and you say, okay, just 5.05 improvement would be enough for me, then you would need 6 million of users. So it's not definitely for normal, or I would say small business, unfortunately. You may read about the 41 Shades of Blue experiment. It was run by Google, and at Google you have ads above a search result, and these ads, the links that they have color, and the color is blue, and they tested 41 shades of this blue, and well, they end up with one winner, and the revenue of this experiment was $200 million. So it really worth to do this. It was about links in search and Gmail, but you simply don't have users for this. So well, this is kind of example I've met many times. The colors of buttons and stuff like that, I think most of the websites are simply not big enough to test this. So I cannot recommend do this. And on the other hand, you can get the statistically significant results even with 5 users. So this is very different thing because between statistically significant results and trustworthy results. How to escape from this? Compute the number of users before the test. Okay, I have some recommendation later. So yeah. So, yeah, Clyman's law, any figure that looks interesting or different is usually wrong. Please be honest to yourself. This is, I think A/B testing is more about culture than about anything else. I really, I love this, but it requires some kind of cultural changes in the organization. So be a skeptic. I think that's the word. Be skeptic to the results, even if the results are positive or negative. So some rules. As I said, compute the number of users in advance, but before the test start. I think this is really crucial. Some tools allows you to stop the test if they have enough data for statistically significant results. This is wrong. There are tons of simulators, or not tons, but there are some simulators on the web, and you risk that the answer is simply wrong. So don't skip the results before reaches this pre-compute sample size. Have enough data, yeah, that's, I think this is most crucial one. I know it's difficult. I know it's difficult, but well, if you don't have enough data, there are some tips. You have to, for example, in medicine, you don't have you don't want to test a new vaccine on 100,000 people. But the difference is between medicine and online world is that medicine has the minimal detectable effect is something like 50% or more. But in online world, we usually have something like 10% is big win. So that's the difference. So if you have not enough data, try to aim with a change that have more impact. The effect is bigger. Then you need less data. Of course, do your math properly. Well, I really recommend if you use some A/B testing tool, plug your numbers into different tool and just compare these numbers. Don't trust the results, never. If the result is positive, run the test again. If it's not, don't do that, because with this 5% p-value, if you run the test repeatedly, there is a higher chance that you measure something just by chance. And yeah, compare the results with other methods like questionnaires, or there are exit polls on your website. There are tons of different methods how to get some feedback. So compare this result. Yeah, I usually prefer Bayesian approach because the interpretation of the results, because it's not something like we rejected null hypothesis with this p-value and blah blah blah. And it's a really, I think, yeah, it's non-intuitive. In Bayesian world, you have a direct probability and that's it. Well, there are some problems with both, so it's not a silver bullet, but use more metrics, as I said, than one. Yeah. A/B testing. Not sure if you heard about this. I really recommend do all the time AA testing. It's a very good technique to test your A/B testing environment. Of course, in A/A testing, you should not measure anything. Well, 5% of these tests would be false positives, but that's okay if your test is set up properly. Yeah, I've met developers that were surprised by this simple technique, but it's really useful. Let's just we did AA, BB, ABBA test, so so it works. Exclude robotics traffic. Yeah, you don't want to usually you don't want to measure your website on Google Robot or Seznam Robot or something like that, because it affects your results. If you can detect this, sometimes it's difficult. I recommend exclude outliers. I mean power users, for example. I know a company where 2% of users generate 50% of revenue. You should, I think A/B testing is not a tool for power users usually, because they are, the group is usually small and you can test new thing on them in a different way. So this really depends what do you test, what the new feature is about. So, but for most of the tests, usually outliers are just bad. Yeah, it's 5 years old article about testing at Google and Bing. And basically they say that just 10 to 20% of experiment actually generate some positive results. This is really cruel word, I would say. And this is just that experiment generate positive results. It doesn't tell anything about the actual deployment. So yeah, as I said, A/B testing is about cultural change in the organization. You have to be prepared that you have to fail in a very fast way, and you have to have a very short loop to be able to test a lot of things, because most of the tests will just fail to be the baseline. And I think that's it. Thanks a lot for the invitation.
All right, thank you for the talk. I really liked it. Are there any questions right now from the audience? Yeah, go ahead.
Yes, English. I wanted to ask you if you said that use more metrics, but what do you do with them then?
Well, for each metric, you compute these p-values and fancy stuff like that. And well, in some metrics, the version B will be better usually. In some metrics, the version B will be worse. And it depends on your business, what's more important or not. You should have something that is called the overall criterion, which actually says, okay, this is something we rely on. So, but you know, as I said, for example, click-through rate is very easy to boost.
Yeah, no, I'm asking because of the simultaneous problem testing. It's exactly like you say with your A and A. If you have many tests, then even if everything should not reject, then 5% will reject. You will always have 5% of green metrics, always.
Yeah.
And it's exactly the same problem. So I think the overall criterion should be, and then you need the different critical values and different user numbers and everything. If you see what I mean, precisely like you mentioned for AA testing, that the reason why you do.
Yeah. This is how these p-values work. So
but that should be overcome by one overall criterion.
There is because it's you always have just a sample. You don't know the reality. So you can be never sure what's better. That's the problem with this, and the statistics just helps you to do a good estimation whether it's good or not. but you can be never sure for 100%. It's not possible. You can the p-value is not to be 5%. It could be just 1% or 0.5%. But then you don't need 6 million users, but 60 or I don't know.
Yeah,
Much more. So that's a problem.
And also, if you need more metrics, maybe you will need also more data, or
I mean, the number of metrics is not about data. It's well, you could, for example, you could use, I don't know, revenue and click-through rate as a combination or something like that. For example, in maybe Tonna could answer that well, because at ad usually they look at money, right? So you could have some metrics you could have green numbers, but where money are red, then unfortunately we cannot deploy this.
I also wanted to ask you about the asymmetry between the null and the alternative, because the way the null is set up is very asymmetric. It's like favorable to the alternative because it's very difficult to reject.
Yes.
And so it's dangerous to the moment you decide to which one is the null and which one is the hypothesis. B beats A or A beats B. You kind of help one of them already in advance.
Yeah. Usually the current system is version A, and what they do at Bing, it's also interesting. If the test was successful and repeated test was successful and everything went well, then they deploy the new feature. When the old version still have some traffic, like fraction, 1%. So, and they still run the A/B test, and the new version is version B, and it should underperform the new version still. So they it's like a cross check that it still work well. But as I said, it's well, it takes some time and resources to implement all these recommendations to some kind of robust framework. So.
Well, I think you have decisions theory where the error of type 1, type 2 might be weighted. It's like a cost of the error. It makes it kind of symmetric, and it removes some of the problems.
Well, I think this is really dependent on the business, whether type 1 error. I think that the risk that you overlook a good opportunity, so that's type 1, and then we have the risk that we just yeah, and well, I'm just switching my head from type 1 to alpha and beta. Okay, anyway, I think this really depends on the business. Whether type 1 or type 2 error is what's more important. Usually, I think that most of the businesses are just conservative. So they don't want to deploy something that is worse than the current version.
Yeah.
And they don't care if, we accidentally miss the opportunity. I think this is usual way of thinking. But it really depends if you are, risk more, then.
Well, this reminds me, one of the econometricians looked at the medicine literature, and it was COVID, and they were doing vaccines, and they were preparing new vaccines, and they were testing very rigorously, like usual, if the new vaccine is better than the old one. And they were always putting the new vaccine as a new one, the B, the one disadvantaged. And exactly as you say, most of the time they rejected the new vaccine, and they started to be desperate, because maybe that's why the vaccine took so long, because the rigorous tests were always rejecting the new vaccine, but because of the asymmetry of the null and the alternative, that was a serious problem.
Yeah, well, actually, I didn't know that they comparing two vaccines, which one is better. I always thought that it's usually just compared to kind of placebo. I'm not in medicine world, so yeah, I agree. I agree. It's and the problem is that you work with real people, real pain, and so it's not just numbers we have. So it's very the world there is much more difficult. And this is it's all about the minimal detectable effect. So maybe you don't have enough patience to detect the change, the small differences between two vaccines. So yeah, but and the asymmetry. Well, you can always compute. You can always compute the opposite as well. So
yeah, I think it should be done because it seems to me from what you say that A and B is kind of if you have one color or other, it's kind of like the same. In medicine, maybe the new vaccine will cost a lot to start to produce, and I don't know. I'm not for medicine, but
I think that the biggest issue is actually the testing on real people. I think this is okay. Okay, the chemistry behind this is expensive as well, but I think then the testing on real people is the real issue.
Yeah, but the problem that you want to answer is symmetric in this case.
Yeah, I understand. I understand.
Testing.
I don't know, to be honest.
So if there are any questions online, feel free to unmute yourself. Otherwise, are there any questions here in the room? Right. Yeah.
I have three comments. As you said, that in Microsoft they save the model and maybe run 1% A/B test on. In SysNum, we did something similar. We saved the old model and ran the BA test after a couple of months because in the relevance web search, we had some features which incorporated human behavior. So like the old model, the control is learned on the real people, and the new one is not. So it has a really huge disadvantage. And we found that it was the result was not symmetric actually. Second, instead of p-value frequentist testing and biasing statistics, you can do bootstrapping. It's not as mathematically beautiful, but it's mathematical enough, and it's.
The advantage of bootstrapping is that there is no kind of requirements on distribution. You know, the frequentist requires a normal distribution, and in bootstrapping it has advantage that there could be any distribution. So that's great. Yeah, the bootstrapping
but you have to have a lot of data.
Yeah, you have a lot of data, right?
And also maybe it also applies just to the big data environment. Sometimes you want to split the users on some other criterion, like in SysNum, as you said, the CTR metric it can be misleading. We found that when people wanted just to click on a specific website, then the CTR was a good metric. Like the query was Facebook, and they just wanted www.facebook.com. But then when they wanted to find really specific information, then the CTR might not be good because they might have already find the information in the featured snippet, for example.
Yeah, exactly. And then this is why I recommend more metrics, because, for example, CTR, you should also measure something called dwell time, or how fast the user will go back from the website back to the search. I know that it says now use that, but yeah, exactly. The one metrics is usually not enough. It's just make you more blind.
So any other questions? Yeah. Right. I have one, to be honest. I wanted to ask you about the automatic stopping of A/B tests, because so you mentioned your opinion that you don't really like it.
Well, it's not my opinion. It's based on statistic.
Okay. Yeah. I'm on the same side, but one thing I wanted to ask about is when you come up with the required number of users, you sort of need an estimate of how big a change you expect, right? Because
yeah, and that's difficult. It's I have it there. It's well, the minimum detectable effect you have to just estimate it by human. It's not it's by some experience or. But
Yes.
usually, if you run the website for some time, you know what to expect. You know that changes more than 10% are really unlikely. Depends on the metrics, of course.
Right.
But, so yeah, but yeah, I got the point. It's purely human experience, nothing.
Nice. Thank you. Yeah, that's exactly what I was aiming for. Right. Yeah.
I would like to disagree with, because I don't know, the research is relatively new, but you can stop before you reach the.
But there are techniques. There are techniques that allows you to stop the experiment in a safe way. But usually, when you compute this, usually unless the difference is so big, or you have eventually enough data, well, it's equivalent. There are techniques. There are formulas how to stop the experiments early. For example, for Bayesian, there are many good approaches, but you cannot escape from if you from this. So at the end, there are some situations where can you stop early because, for example, the effect is big. So yeah, in general, I cannot recommend this. And then also techniques how to I have these formulas there for p-values 5%, quarter of million of users. There are techniques how that you need less of users if you have enough historical data. You can pre-compute something, and you say, okay, the distribution is same as this historical data. Usually, you have tons of historical data. And not so many data from the test. So, yeah, there are some ways how to make things better.
Yeah. It's something like when you are counting the votes in the election, and when there is still a margin of 2%, and they need to decide if you count how many people have not been counted, you can stop or not stop, but you
in votes, it's you know the population. No, it's usually it's fixed.
Your pre-computed number that you think you will need, and you will not need it in the end.
Okay, if you yeah, that's right.
And it's exactly like you say, even if you have the new data and you go and you measure, it's like you are creating the history. It's exactly the same thing.
Yeah, and just one more comment on the AA testing. You can do AA testing on historical data. You don't have to run it online at all. You can test, for example, you're splitting your users on just your data from logs. So it could be done in this way as well. It's very useful, and it can point some problems in logging as well. So it's no risk. It's no risk thing. So.
All right. So unless there are more questions, well, let us thank the speaker one more time.
Yes, thank you.
And then just some small things about organization. We already know the date of the next Mid-on Times. It's going to be on the 13th of April. It's going to be by BAYESIAN about their segmentation models. So, you know, just keep up with the meetup.com where we will post the announcement shortly. And yeah, for everyone here, pizza is probably already at the reception, and then we'll go for a couple of beers if you're interested. And, you know, thank you all for coming. Thank you, Vlade. It was very interesting.